Hello friends and welcome back to our channel Infinity Learning. So in today's lecture we are going to discuss the two different techniques of the coding, the Shannon coding and the Huffman coding. In the previous lecture we stopped in the different types of codes and just named the different types of coding techniques. So today this will be the second part of the source coding part of the subject. So proceeding with the first coding technique, that is the Shannon coding. This is the algorithm that we need to follow. So the first step is arrange the source symbols in the order of their decreasing probability. So we need to arrange the probabilities in the descending order. The second step is we need to divide the whole set into two levels in such a manner that the sum of the probabilities of both the set is nearly equal to each other. The third step is we need to assign 0 for the higher set or upper set which have higher value, and the lower set will be assigned with 1. And the fourth step is we need to repeat the second and third step until each subset contains a single element. So I know this algorithm is a little bit confusing for now, but as we will solve a problem related to the coding technique, the algorithm will become clear and it will be very easy for you to understand. So the question says DMS X gives 5 symbols x1, x2, x3, x4, x5 with probabilities 0.4, 0.17, 0.18, 0.1 and 0.15. We need to construct the Shannon code for the DMS X. So proceeding to the solution, the first step is we need to rearrange the values in the descending order of the probability values. So they will 0.4, then 0.18, then 0.17, then 0.15 and then 0.1. I will write the symbols near them: x1, x3, x2, x5 and x4. Now the second step is we need to divide the whole set into two sets such that the sum of both the sets is nearly equal to each other. So the best case here will be the first two elements and the last three elements. So if we group them, so this will be 0.58 and this will be 0.42. So the second step is completed. The third step is we need to assign the upper set with 0 and the lower set with 1. So the upper set has two values, so both the values will be assigned as 0, and the lower set has three values, so the three values will be given 1. Now the fourth step is we have to repeat the second and third step again until and unless a single element is reached. So the second division will again divide the first set and the second. So the first set consists of two elements, so the upper value 0.4 will be assigned 0 and the lower value 0.18 will be assigned 1. Now the lower set consists of three values, so it will be again divided into two sets. So the best case here would be 0.17 and 0.25. So this will be assigned 0 and the lower set will be assigned 1. Now as we can see that the lower set contains two elements, so another division will take place. So here 0.15 and 0.1 are the last two elements, so the 0.15 is the upper set, so it will be assigned 0 and the will be assigned 1. So the final codes are x1 equal to 0 0, x2 equal to 1 0, x3 is equal to 0 1, x4 is equal to 1 1 1 and x5 is equal to 1 1 0. So this is the required Shannon coding for the given DMS X. Now we can easily find the efficiency of this method. As we know, efficiency eta is equal to entropy Hx by L, that is the average code length. Now average code length we know is equal to summation pj nj. From our last lecture we know this. So this will be equal to 0.4 into, so zero point 0.4 is for x1 and the length of code of x1 is 2, so it will be 0.4 into 2 plus, so x2 probability is 0.17 and 0.17 into 2, again then 0.18 into 2 plus 0.1 into 3 plus 0.15 into 3. So this will be bits. So this will be equal to 2.25 bits. Now we also know the formula for entropy, which is equal to minus summation of pj log of pj. So this will be minus 0.4 into log 0.4 and base will be 2 minus 0.17 into log 0.17 minus 0.18 into log 0.18 log 2 minus 0.1 into log 0.1 base 2 minus 0.15 into log 0.15 base 2. So after calculating it we will get the value 2.15 bits per symbol. So we got the value of entropy and the average code length. Now we can easily find out what is the efficiency. So this will be 2.15 by 2.25. This will be equal to 0.95, which is 95%. So we can see that the efficiency for this coding technique is very high and it is above 90%. So this is a preferable coding technique for the receiving and transmission of the message bits. So this was the basic concept of Shannon-Fano coding. So now let's move to the second coding technique, that is the Huffman coding. Now the second technique, that is the Huffman coding. This is the algorithm we will follow. So the first step is that we need to list the source symbols in order of their decreasing probability, similar to the Shannon-Fano one. The second one is we combine the probabilities with the smallest values and reorder the resultant probability. The final reordering is called last reduction. So we need to combine the smallest two or the last two probabilities, then sum it, and the value is will be rearranged with the remaining values, and this rearranging will go on until the final reordering is reached, which is known as the last reduction. The third step is start encoding from the last reduction, that is the last reordering, and assign 0 to the higher value and 1 to the lower value. And the last step is we need to repeat the steps until the first column is reached again. So similarly we can apply this coding technique for the similar type of question, that is the DMS x gives x1 x2 up to x5 and the probability value are same. Now we need to construct the Huffman coding for the DMS x. So the solution will be, the first step is we will reorder the values in their decreasing value. So 0.4, 0.18, 0.17, 0.15 and 0.1. The symbols are x1, x3, x2, x5 and x4. Now the second step says that we need to add the last two probability values, that are the smallest values, and now we will rearrange the whole set according to that combined value. So combined this will produce 0.25. Now with 0.25 these three values will be rearranged again in the decreasing order of their probability values. So now it will be 0.4, then 0.25, then 0.18, then 0.17. Now the fourth step says that not a necessarily fourth step. Now we need to repeat this step again and again until a last reduction is reached where we will get only two elements. So again we will combine these two lowest values, so we will get 0.35. So again we will rearrange it, so this will be 0.4, this will be 0.35, and this will be 0.25. Again we will rearrange it, so this will be 0.6 and this will be 0.4. Now after this step we are unable to do the reductions furthermore, so this is the last reduction, the last reordering. Now the third step says that when the last reduction is achieved, we will start assigning the values from the last reduction up to the first column until the first column is reached. Third step says that the higher probability will be assigned 0 and the lower probability will be assigned 1. So the higher probability here is 0.6, so it will be assigned 0. Sorry, it will be assigned 0 and the lower probability will assign 1. Now going to the back column, 0.4 remains the same, so this will be 1, but 0.6 is the result of the combination of 0.35 and 0.2, so the starting bit of both the data will be same as for 0.6, that is 0 0. Now for these two elements the higher value is 0.35 and the lower value is 0.25, so 3.35 will be assigned as another 0 and 0.25 will be assigned a 1. Again back to the previous column, 0.4 will remain same, 0.25 will remain same. Now 0.35 comes from 0.18 and 0.17, so these two values will have the same starting code word as the 0.35, so this will be 0 0 and this will also start from 0 0. Now 0.18 is higher, so it will get another 0, and 0.17 is lower, so there will be a 1 in the last. So now this is the our starting column, so we are returning back to it, so this will be the last step. So 0.4 will remain same, 0.18 is 0 0 0, 0.17 is 0 0 1. Now 0.25 comes from 0.15 and zero point 0.1, so this will have same bits starting with same bit, so this will be starting with the same bits as 0.25, so 0 1 and 0 1. Now 0.15 is higher, so it will be assigned 0, and 0.1 is lower, so it will be assigned 1. So this first column will give the final code structure of the Huffman coding technique. So the final codes will be as for x1 it will be 1, for x2 it will be 0 0 1, for x3 it will be 0 0 0, for x4 it will be 0 1 1, and for x5 it will be 1 0 1 0 1 0. Sorry. So again we will calculate the efficiency and see whether Shannon-Fanon was more efficient or Huffman coding was more efficient for this particular question. So similarly eta is equal to hx by L, so hx is minus summation pj log pj base 2 and L is summation pj nj. Now the probability of all the factors will remain same, so there will be no change in the entropy, so this will remain same as the previous one, so this will be 2.15 bits per symbol. But here the varying factor is the size of the code word, that is the n, so the length will be different from the previous case, so this will be 0.4 into 1 plus 0.17 into 3 plus 0.18 into 3 plus 0.1 into 3 plus 0.15 into 3. So this will come up to be 2.20 bits. So now we can easily calculate the efficiency, that is 2.15 by 2.20, which will come out to be 0.98. It will be a approximate value. So this will be equal to 98%. So here we can see that for this particular case, the Huffman coding is more efficient than the Shannon-Fano coding. But this might not be the case always. The Shannon-Fano coding can have greater efficiency for a particular type of case. So it depends on the questions and the procedure of the solution. So these were the two basic techniques of the coding part, and for the for this reason, because the efficiency is more, so the process is more optimal. So this is also known as optimal coding technique. Optimal coding technique. So these were the two coding techniques that we are required to know about, that we will use further in the different applications in the fields of the different fields of the subject. So this is it for this video. I hope you like the video. If you, please give it a thumbs up and subscribe to the channel for more this kind of videos, and I hope we will meet in the next video again. Thank you.